All right, let's go. Number 10. The atlatl hook of Combe and the weapon that multiplies the human arm. In 1986, a team led by archaeologists Jean-Michel Geneste and Jean-Pierre Chadel was in the middle of a long excavation campaign running from 1978 to 1996 at Combe, a rock shelter site in the Dordogne region of southwestern France. In the upper Solutrean level, they recovered a small object carved from reindeer antler barely long enough to fill a hand. It looked unremarkable next to the more than 400 stone point fragments and 12,000 animal bones the site would eventually yield. Archaeologist Pierre Catalan, who formally described it in 1,989 inches. The Bulletin de la Société Préhistorique Française recognized what it actually was, a spear thrower hook, the working end of a device built to do something no human arm can do on its own. Radiocarbon dating places the object at approximately 17500 years old, making it by most current accounts the oldest confirmed physical spear thrower ever recovered anywhere on Earth. The mechanics are simple enough to explain in a sentence, and difficult enough to master, that it took our species tens of thousands of years to build one. A rigid shaft with a hook at one end engages the butt of a dart, extending the effective length of the throwing arm and multiplying the velocity delivered at release. A skilled user can send a dart well past 100 meters, with a reliably lethal range far beyond anything achievable by a hand-thrown spear. Of roughly 115 confirmed spear thrower hooks, known from 37 sites, concentrated mostly in southwest France, with others scattered across Germany, Switzerland, and Spain. Nearly all of them belong to the Magdalenian culture, dated to between about 19 and 14,000 years ago. The Combe hook sits alone, thousands of years older than almost everything else in its own category. That isolation is itself the discovery's most unsettling feature. But here's where the object stops being simply old and starts raising a harder question: indirect trace evidence from a separate site. Mazier's Canal in Belgium has produced fracture damage on stone points that researchers argue is consistent with spear thrower use, dated to roughly 28 to 31,000 years ago. Over 10,000 years before Combe hook was carved, and more than 10,000 years before the technology's next confirmed physical appearance anywhere in Europe. No spear thrower survives from that earlier period. Only the wounds it may have left behind do. What that gap implies is not that the technology was invented once at Combe and then vanished for millennia before resurfacing in the Magdalenian. It implies the opposite, that a functioning mechanical weapon system, precise enough to leave a signature on the bones of the animals it struck, was already circulating across Ice Age Europe for tens of thousands of years, almost entirely invisible to us, because the parts of it that mattered most, the wooden shaft, the leather or sinew grip, the fletchings, simply rotted away before anyone could find them. The hook is not the weapon. It is the one component durable enough to outlast its own disappearance, a fragment standing in for a complete system we will likely never see whole. Somewhere in that missing wood and hide sits the actual history of the atlatl, decades or centuries or millennia of refinement that left no trace anyone has yet found. What survived at Combe is not evidence of a beginning. It is evidence of how much of the beginning is already gone. Number 9. The Mammoth Ivory Boomerang of Obwazoa Cave and the Weapon, rewritten by its own redating. In 1985, archaeologists excavating Obwazoa Cave in the Podhale Basin of the Western Carpathians in southern Poland recovered a crescent-shaped object 72 centimeters long, carved from a mammoth's tusk. It lay in an exposed position within the cave, surrounded by large stones that appeared to have been deliberately placed alongside a human thumb bone, fox-tooth pendants, antler tools, and a heavy scatter of red ochre. Archeologist Paweł Waldenowak. Now, a professor at Jagiellonian University in Krakow has studied the site for decades, and the object's identity was not seriously in question. Its arched shape and flat convex cross-section matched almost exactly the non-returning boomerangs still used by Aboriginal communities in Queensland, Australia, a design most people assume belongs to one continent and no other. What has changed repeatedly is the object's age, and each revision has mattered. Early radiocarbon testing suggested a date of roughly 18,000 years, a figure later judged unreliable due to contamination introduced during the object's own conservation. A subsequent estimate placed it within the Pavlovian culture between 23 and 30,000 years old, which would already have made it the oldest known boomerang on the planet. Then, in June 2025, a team led by Sara Talamo of the University of Bologna, working with Valda Nowak and Adam Natakowski, applied Bayesian radiocarbon modeling to bones recovered from the same layer, publishing their results in PLOS One. The new calibrated range for the boomerang itself between roughly 42,290 and 39,280 years before present, with the cave's main occupation phase running slightly vidar, from about 42,800 to 38,500 years ago. 42,000 years does more than extend a single object's biography. It pushes confirmed Homo sapiens' presence in this part of Europe back into a stretch of time, once assumed to be functionally empty of our species, a gap between the last Neanderthals and the first secure evidence of modern humans that researchers had treated as a genuine population vacuum. The boomerang redated closes part of that vacuum by itself. But here's where the object refuses to resolve into a single tidy explanation. A non-returning boomerang of this type is not a specialized hunting tool in the way a modern archer's bow is specialized. Ethnographically, the same design has served as a combat weapon, a butchering implement, a digging tool for wells and cooking pits, an ash scraper for pulling roasted meat from a fire, and a percussion instrument. Valda Nowak has proposed that its final placement in the cave, coated in red ochre and set beside human remains, points toward ritual significance, layered on top of, or instead of, everyday use. Both readings can be true of the same object across its lifetime, and nothing about the physical evidence forces a choice between them. What is not ambiguous is the engineering. Someone working in ivory, rather than wood, understood curvature, cross-section, and mass distribution well enough to produce a shape that still flies true today, recognizable at a glance to a culture on the opposite side of the planet that would not develop its own version of the same idea for tens of thousands of years using a completely different raw material with no possible contact between the two traditions. The aerodynamics were solved once in a cave in the Carpathians, by hands working mammoth tusk under conditions of Ice Age cold, and then solved again independently, half a world and 40 millennia away, because the physics never gave either group any other option. Number 8. The heat-treated points of Pinnacle Point and the fire you cannot see working. At Pinnacle Point, a cluster of caves above the Indian Ocean near Mossel Bay in South Africa's Western Cape, archaeologist Curtis Marian of Arizona State University's Institute of Human Origins has directed excavations for more than 2 decades, work supported in part by grants from the National Science Foundation. Working with colleague Kyle Brown, Marian's team examined stone tools recovered from a layer inside Cave 13B made from a fine-grained rock called silkrete, and noticed something the raw material shouldn't have been capable of on its own: a glossy, altered surface texture and flaking properties consistent, not with the stone as it occurs naturally, but with stone that had been deliberately heated before it was worked. Published in Science in 2009, their analysis, co-authored with a team of geochronologists and archaeologists, placed this heat treatment at approximately 164,000 years old, the earliest confirmed instance of the practice found anywhere. Untreated silkrete is difficult to flake with precision. Heated correctly, its internal crystal structure changes, and it becomes dramatically easier to shape into finer, sharper, more controlled cutting edges. A follow-up study led by Vincent Moore Paulavilla and Christopher Henshelwood, published in Science in 2010, examined bifacial points from Blombos Cave, roughly 75,000 years old, and found that the same heat treatment there had been applied specifically to enable pressure flaking, a controlled technique for removing small, precise flakes, along an edge that specialists had long assumed was a European invention from around 20,000 years ago. The South African evidence moved that origin back by more than 50,000 years. What makes this different from simply building a fire is the invisibility of the process itself. You cannot watch stone change as it heats. The transformation is internal, chemical, and delayed. Bury a piece of silkrete near embers or beneath a bed of heated sand. Wait, remove it, let it cool, and only then, hours or days later, does the improvement reveal itself in how cleanly a flake comes away under the knapper's hammerstone. Succeeding at this repeatedly, reliably, across generations requires holding an entire causal chain in mind, without any direct sensory feedback, linking the cause to the effect until long after the cause has finished happening. But here's where the achievement stops looking like an isolated trick and starts looking like a genuine engineering discipline. Heat treatment demands a narrow temperature window, too cool and nothing changes, too hot and the stone fractures or discolors into uselessness. Modern experimental archaeologists reconstructing the process have needed careful thermometry to hit that window consistently. The people at Pinnacle Point and Blombos had no thermometers. They had fire, sand time, and an accumulated transmitted understanding of how long was long enough, refined by trial and error, and passed down with enough fidelity that the results tested against modern flaking mechanics hold up. This is not decoration. It is not symbolic behavior in the sense of an engraving or a bead. It is applied materials, science executed on a process whose mechanism nobody involved could see, smell, or otherwise directly observe, while it was happening at a depth of time when most 20th century accounts of human cognition assumed nothing this abstract was yet possible. A species not yet fully certain of its own future was already manipulating the internal structure of matter through a method with no visible moving parts, trusting a delay between action and result that stretched in practice across an entire afternoon spent waiting for a rock to finish becoming something else. Number 7. The ivory-tipped spears of Yana RHS and the weapon built to be broken. The Yana River empties into the Arctic Ocean at 71 degrees north in a stretch of Siberia so remote that a foreshaft carved from woolly rhinoceros horn, weathered out of frozen ground along its bank, sat unexamined for years, after it was first noticed, before archaeologist Vladimir Patulko of the Institute for the History of Material Culture at the Russian Academy of Sciences in St. Petersburg began formal excavations in 2001. What his team found, buried beneath roughly 30 feet of permafrost, was a Paleolithic campsite complex, now known as the Yana Rhinoceros Horn Site, or Yana RHS, containing around 2,500 worked bone and ivory items and some 6,000 beads, alongside stone tools and the remains of bison horse and reindeer. Published by Patulko and 8 colleagues in Science in 2004, the dating placed the site at approximately 27,000 radiocarbon years, before present roughly twice the age of any other confirmed human occupation. Anywhere in the Arctic at the time, squarely within a glacial period rather than a warmer interval. Among the recovered weaponry were multiple foreshafts, separate replaceable tips of mammoth ivory and rhinoceros horn, designed to be socketed into and removed from a single reusable wooden spear shaft. That design choice is the discovery's real weight. A hunter using a fixed one-piece spear who breaks the tip on impact with a mammoth or a horse has lost the entire weapon in a landscape where a replacement shaft might mean a day's search for suitable wood that this far north may not exist within any practical walking distance at all. A hunter carrying spare foreshafts loses only the tip, reseats a new one in seconds, and returns to the hunt. It is a modular system built around the assumption of failure engineered, so that failure costs the smallest possible piece of the whole. A design logic that would not look out of place in a modern discussion of field serviceable equipment. But here's where the site complicates the standard timeline for how humans occupied the far north. Long-standing models held that deep Arctic settlement waited for the retreat of glacial ice, when warmer, more forgiving conditions made survival above the 60th parallel plausible. Yana RHS sits at over 70 degrees north, fully committed to glacial period cold, thousands of years before that retreat began, and its inhabitants were not merely enduring the environment. They were carving engraved ivory tusks, one bearing a figurative composition incised across its surface, shaping small zoomorphic figurines close in scale to comparable pieces recovered from Kostenki, 11 inches western Russia, and stringing thousands of beads, evidence of a population, with enough surplus time and security to invest heavily in the symbolic, not only the functional. Patulko's excavation resuming across multiple field seasons after that first 2001 campaign deliberately worked outward from the original foreshaft find in concentric expansions, a slow, patient strategy suited to a site where every meter of frozen overburden has to be removed by hand before anything underneath can be seen at all. 30 feet of frozen ground kept a fragile modular weapons system intact for 27,000 years in a place most modern visitors wrapped in synthetic insulation and carrying satellite phones could not survive a single unprepared night in. Some of the same broad Siberian ancestry connected to populations like this one would go on in later millennia to cross into a continent nobody in that camp could have imagined existed, carrying in some form to the same basic engineering logic forward with them. Never let one broken point cost you the whole hunt, and never build a weapon you cannot repair with what you are already carrying. Number 6. The Swords of Arslan-Tepe and the weapon that predates its own word. Near modern Malatya, on the upper Euphrates in eastern Anatolia, the mound of Arslan-Tepe has been excavated by an Italian archaeological mission from Sapienza University of Rome since 1961. In the early 1980s, working within a late Chalcolithic palace complex, the team publishing under Alba Palmieri and Marcella Frangipane in the journal Origini in 1983 uncovered a cache of 9 weapons cast in arsenical copper in a room designated A113. Frangipane, who has directed the mission since 1990, has led the extensive research on the find in the decades since. 3 of the 9 objects, measuring between 45 and 60 centimeters, are unambiguously short swords, complete with a blade, a guard-like transition, a grip, and a pommel-shaped terminus, the full anatomical vocabulary of the weapon as we would recognize it today. 3 more carry delicate silver inlay in triangular patterns. A later metallurgical reanalysis of the collection by researcher Dino Serra calculated an average blade length of 50 centimeters and an average weight of 521 grams across the set, ranging from a longest specimen of 62 centimeters and 960 grams, down to a shortest of 45.9 centimeters and 410 grams. A slightly later context at the same site, a so-called royal tomb, dated to roughly 2900 to 2750 BCE, produced a further sword and 9 spearheads. The palace complex cache itself is dated through calibrated radiocarbon to approximately 3400 to 3000 BCE, and the mound has been recognized as a UNESCO World Heritage Site. Its original swords and daggers now held in the Malatya Museum. Before this discovery, the working assumption among most archaeologists was that the true sword, as opposed to a long dagger, did not appear anywhere on Earth before roughly 1600 to 1500 BCE. Arslan-Tepe's blades predate that assumed threshold by close to 2,000 years, and they are not primitive or transitional. They are not in the words specialists studying them have used almost swords. They are swords cast with evident confidence in a design already fully formed. But here's where the object's polish becomes its own kind of evidence. Metallurgists studying the Arslan-Tepe cache have argued the smiths were not inventing the sword's form from nothing. They were translating an already familiar shape, one that must have existed before this, in perishable materials. Wood or bone cores wrapped in thin metal collars into the new medium of cast arsenical copper. Those organic precursors, if they existed, are gone, most likely melted down and recycled as their metal components aged out of use, along with whatever record they might have left of how much older the underlying design actually was. Whether these blades were carried into combat, displayed as proof of status, or as is likely served both purposes depending on the day and the wearer, remains a live question among the researchers who study them. Even at a modest 60 centimeters, wielded by an early Bronze Age fighter, they would have been formidably lethal, whatever ceremonial role they may also have carried. Arslan-Tepe's occupation stretches back to the 6th millennium BCE and continued through the later Bronze Age into layers containing recognizably Hittite material, a militarized empire that rose in the same region centuries afterward. And some specialists studying the site have wondered aloud whether that later tradition of organized warfare owed something even indirectly to smiths working in this same palace complex first. What is not in question is what a sword is for. It has one function that a knife, an axe, or a digging tool does not share. It exists to end a human life, at close range, with intention and nothing else. That purpose was cast in silver inlaid metal inside a palace, in a city that had not yet developed a system of writing to record a single law, a single name, or a single reason. The sword, in other words, may be older than the sentence that could have explained why anyone needed one. Number 5. The poison applicator of Border Cave and the debate that will not close. Border Cave sits in the Lubombo Mountains on the border between South Africa and Eswatini, a site excavated across decades and analyzed in detail by an international team led by Francesco De Rico alongside Lucinda Backwell of the University of the Witwatersrand and Paula Villa of the University of Colorado Museum publishing their findings in the Proceedings of the National Academy of Sciences in 2012. Among the organic artifacts they recovered, and directly dated, was a fragmented wooden stick, its surface cut with a pattern of perpendicular notches dated to approximately 24,000 years before present. In shape, it closely resembles poison applicators still used today by sand hunters in the Kalahari thin sticks, notched to hold and carry a paste of toxin for coating an arrow's tip. Gas chromatography run on residue extracted from the border cave stick identified ricinoleic acid and ricinoleic acid, the primary chemical components of castor bean oil derived from a plant Ricinus communis common across the region. The castor bean is also the source of ricin, one of the most lethal natural toxins known. If the applicator's function is what D'Errico's team proposed, then people in that cave 24,000 years ago were identifying a locally available plant, extracting or concentrating a compound from it, and applying it deliberately to weapons, using chemistry to accomplish what a small stone or bone arrowhead alone often cannot, converting a survivable puncture wound into a fatal one. The same excavation recovered a lump of beeswax mixed with euphorbia resin, dated to roughly 40,000 years old, and likely used for the oldest confirmed use of beeswax as a tool material anywhere on record, alongside a wooden digging stick dated to about 39,000 years and ostrich eggshell and marine shell beads dated to around 42,000. One recovered bone point carries a spiral groove filled with red ochre, a decoration that closely parallels the markings sand hunters still cut into their own arrows today to identify individual ownership during a communal hunt. But here's where the interpretation ran directly into a formal published challenge. Archaeologist Adrian Evans of the University of Bradford, writing a direct rebuttal in the same journal later that year, pointed out that ricinoleic and ricinoleic acid are not by themselves poisonous. They are simply the ordinary chemical signature of castor oil, a substance also documented in local use for preparing animal hides. And an ethnographic review found castor derivatives recorded far more often as medicine than as arrow poison. Evans argued the stick could just as easily have served in food preparation, hide treatment, or medicine. D'Errico and his co-authors published a direct reply, defending their reading, as the interpretation best supported by the object's shape and its close resemblance to known ethnographic poison applicators, but the disagreement itself was never formally resolved. What has shifted the ground since is a separate, more recent finding. A 2024 chemical analysis of a bovid leg bone recovered from Kruger Cave, also in South Africa, and used as a quiver holding 3 bone arrowheads dated to roughly 7,000 years old, identified digitoxin and strophanthodin, cardiac glycosides, with no ambiguity about their toxicity mixed, deliberately from more than one plant source. The researchers behind that study noted explicitly that their unambiguous result lends credence to the older contested reading of the border cave stick, since it confirms the same broad category of chemical weapon technology was already established in the same region and continued developing in sophistication over the following millennia. Whether or not that specific 24,000-year-old stick ever killed anything, the underlying premise that a weapon's lethality does not have to come from its edge at all was already understood well enough in that same landscape to be refined and reused for thousands of years afterward, right up through the confirmed poison recipe at Kruger Cave, and into the documented practices of sand hunters, alive today. The argument over the proof of it has now lasted decades longer than most human lifetimes, conducted entirely by people trying to reconstruct a decision made by someone who never once had to justify it to anyone but the animal in front of them. Number 4. The bone arrowheads of Phahien Lena and the weapon built for the canopy. Deep in the rainforest of southwestern Sri Lanka, the cave of Phahien Lena has been excavated by an international team including archaeologist Michelle Langley of Griffith University in Brisbane, working alongside researchers from the Max Planck Institute for the Science of Human History in Sri Lanka's Department of Archaeology. Publishing in Science Advances in 2020, Langley's team described 130 projectile points carved from bone, recovered from sediment dating across a span from approximately 48,000 to 34,000 years before present. The earliest confirmed evidence for bow and arrow hunting found anywhere outside the African continent. The case rests on damage, not just shape. Microscopic and high-resolution imaging of the points revealed fracture patterns consistent with high-velocity impact distinct from the blunter. Heavier characteristics that would be expected of dart tips launched from a blowgun and distinct again from the trauma left by a hand-thrown Dakshius Dakshin spear. Notches worn into the base of several points indicated they had been hafted onto narrow shafts. Many of the points were carved specifically from the bones of monkeys, a detail that identifies the intended prey as clearly as the weapon itself. Fast arboreal animals that spend their lives well out of an ordinary throwing spear's effective range visible for only a few seconds through dense canopy before vanishing again. Rainforest environments had long been treated in the broader literature on early human expansion as a kind of natural barrier, too resource poor and too difficult to navigate for Pleistocene populations moving out of Africa to settle successfully. Fa Hien Lina's toolkit, alongside shell beads, traded or carried from a coastline 20 to 30 kilometers away, and ochre pigments in red, yellow, and a rarer silver tone recovered from the same layers, argues against that assumption directly. A fully modern behavioral repertoire, combining precision long-range weaponry with symbolic material culture, adapted specifically to conditions that supposedly should have stopped it. A companion study of the site's stone microliths, published by Oshan Wedage and colleagues in PLOS One in 2019, documented continuous rainforest occupation at Fa Hien Lena, running from roughly 45,000 years ago down to nearly 4,000. A working record of adaptation to the same demanding environment stretched across more than 40 millennia without interruption. But here's where even the field's own specialists have chosen caution over certainty. Marlies Lombard, the University of Johannesburg archaeologist whose own research on bow and arrow evidence in South Africa runs even deeper into the past, responded to the Fa Hien Lena publication by withholding full endorsement, telling reporters she preferred to see the bone points undergo the same high-resolution CT scanning that had confirmed impact damage on comparable specimens elsewhere before treating the interpretation as fully settled. It is a small telling moment. Even researchers working in the same specialty, examining evidence that supports a shared, broader argument, hold each other to a standard that refuses to accept a dramatic new claim without independently reproducible proof. The same layers at Fa Hien Lena also produced 29 additional bone tools, identified as scrapers and awls likely used for working animal skins and plant fiber, and an implement with evenly spaced notches down each side that the excavators interpret as a shuttle for weaving fishing or trapping nets, evidence of an entire toolkit built around extracting a living from a forest. Most archaeological models still describe as marginal at best. Somewhere in that cave, a hunter who could not outclimb, outrun, or physically approach the animal they wanted had already solved the problem a different way, matching a small carved bone precisely enough to a target moving through branches 15 meters overhead, that the solution left a legible signature on impact, still readable 48,000 years later, long after the particular monkey and the particular hunter and the particular afternoon had been forgotten by everyone who was ever there to remember them. Number 3. The barbed harpoon of Katanda, and the discovery nobody wanted to believe. In 1988, at a Middle Stone Age site called Katanda on the upper Semliki River, in the western Rift Valley of what was then Zaire, archaeologist Allison Brooks of George Washington University and her husband, archaeologist John Yellen, were excavating alongside colleagues when they uncovered a carved bone point with a row of sharp barbs cut along one edge. The find stopped the team's work outright. Nothing about the site's context suggested the object should have been that finely made, and their first instinct, by Brooks's own account, was to suspect the stratigraphy itself had somehow been disturbed or contaminated by more recent material working its way down into older sediment. It had not. Published in Science in 1995, the analysis by Yellen Brooksels, Cornelissen, Michael Melman, and Kathleen Stewart described a well-developed bone industry across 3 separate localities at Katanda, including both barbed, unbarbed points, and a single dagger-like implement dated by a combination of direct and indirect methods, principally electron spin resonance and thermoluminescence, to approximately 89,000 years. with a stated margin, allowing for an age as old as roughly 111,000 years. A companion paper published the same day in the same issue also with Brooks, among its authors alongside a larger team of dating specialists, including geochronologists Henry Schwartz and Jack Rink, of McMaster University laid out the full chronological evidence site by site. Alongside the points, the team recovered abundant. Catfish remains concentrated tightly around the tool-bearing layers, evidence of a specialized organized fishing economy, seasonal, and repeatable enough to be worth investing this much craftsmanship in the equipment built to run it. Barbed bone harpoons of comparable sophistication do not reappear in the archaeological record anywhere else on Earth until the Magdalenian culture of Ice Age Europe, tens of thousands of years later, a gap wide enough that specialists studying the European material had spent decades treating barbed bone technology as a hallmark achievement of the Upper Paleolithic, specifically evidence of a cognitive and technical threshold that supposedly separated fully modern human behavior from everything that came before it. That gap alone made the Katanda dates difficult for much of the field to accept at face value when they were first published, and the skepticism was not casual or dismissive. It was formal, published, and specific, arriving from researchers whose objections centered less on whether the artifacts were genuine and more on whether any dating technique available at the time could really be trusted. This far back applied to a raw material as chemically unstable as bone. But here's where the argument became a genuine, sustained scientific dispute rather than a quickly settled footnote. In 2001, James Feathers and Elena Migliorini published a direct reassessment of the luminescence, dating in quaternary science reviews, raising substantive concerns about the reliability of the original chronology. Brooks and her colleagues answered by anchoring Katanda's stratigraphy to the nearby site of Ishango, whose own age Brooks had already revised upward once before in the mid-1980s using radiocarbon dating that pushed its original 1950s estimate of roughly 8,000 years to closer to 25,000. By that stratigraphic correlation, Katanda sits demonstrably older and deeper than Ishango, which independently supports a very old age even before the specific dating methods are weighed against each other. More than 3 decades on the precise number remains genuinely unsettled in the published literature, not because the harpoons themselves are in doubt, but because dating methods pushed this close to their outer limits carry irreducible uncertainty, and a discovery this far ahead of its supposed technological moment draws exactly the kind of scrutiny an unremarkable one never would. Brooks herself would go on with colleague Sally McBrady to publish an influential reassessment of the wider question in the Journal of Human Evolution in 2000, arguing that so-called modern human behavior did not arrive in one dramatic continent-wide leap during the Upper Paleolithic, as the field had assumed for decades, but accumulated gradually across Africa over hundreds of thousands of years, with Katanda's harpoon standing as one of the clearest single data points for that slower, deeper argument. An object carved with barbs precise enough to hold a struggling catfish against the current of an African river has now outlasted in argument alone every fish it was ever used, to catch every hand that carved it, and very possibly every to assumption its discoverers walked into that excavation already, holding. Number 2. The bitumen-hafted points of El Tel and the chemistry the species that invented it could not outrun. In the El Kaum Basin of central Syria, archaeologist Eric Boeda of the Université Paris Nanterre led excavations at El Tel across more than 2 decades, beginning in the late 1980s, part of a long-running collaboration between the French Ministry of Foreign Affairs and the French Institute of the Near East. The site preserves a long stratified sequence of Mousterian occupation, the stoneworking tradition most closely associated with Neanderthal populations across Europe and the Near East, built around a distinctive method of flint reduction known as the Levallois technique, in which a napper carefully shapes a stone core in advance so that a single controlled strike detaches a flake or point already close to its finished form. In 1996, Boeda and 6 co-authors published in Nature the identification of natural bitumen residue on Middle Paleolithic stone tools from the site, dated to roughly 40,000 years old, the first confirmed evidence that Neanderthal populations had used a petroleum-based adhesive to attach stone points to wooden shafts. A later study by the same team, published in Paleorient in 2008, pushed the practice back much further to a layer designated complex VI3, dated between approximately 71 and 72,000 years, after microscopic analysis found bitumen residue on two-thirds of 300 examined stone artifacts in many cases, invisible to the naked eye, and detectable only under magnification as a dark, glassy film, trapped in the flint surface irregularities. Gas chromatography and carbon isotope analysis trace the bitumen's chemical signature to a specific natural outcrop some 40 kilometers away in the Beachree Massif, distinguishing it geochemically from other known bitumen sources, the wider region. That distance is the detail that turns a simple adhesive into evidence of planning. Someone identified a particular raw material at a particular distant location, judged it worth the return journey to collect, carried it back, and then deliberately heated it, a process confirmed by subtle chemical changes in the material, before applying it to fix a stone point onto a shaft, with enough precision to survive tens of thousands of years underground. The heating itself appears to have been kept deliberately mild, just enough to soften the bitumen into a workable paste, without degrading its adhesive strength, a level of control that implies real repeated familiarity with the material's behavior rather than a single lucky accident involving a stray lump of tar too close to a cooking fire. But here's where the story stops, being one of simple progress and becomes something closer to a mystery with no agreed resolution. The evidence shows this specific hafting practice, sourcing and heating bitumen for use as an adhesive, appears to stop sometime between roughly 70,000 and 40,000 years ago, even as the underlying Levallois point technology. These tools were shaped with continued in use at the same site without interruption. Nobody has established why. The improvement was not built upon in any way visible in the archaeological record. It was not universally adopted elsewhere in the region, based on comparable sites excavated since. It simply recedes, replaced if replaced at all, by some other hafting method, perhaps plant resin or animal-based glue that left no comparable chemical trace for archaeologists to find. What makes this genuinely unsettling rather than merely puzzling is who made it and what happened to them. This is Neanderthal material culture, produced by a species capable of sourcing a raw material across real distance, processing it with controlled heat, and applying it with a precision modern chemists needed a full century of laboratory technique to even learn how to detect. And within the broad span of time that follows this technology's disappearance from El Tel Neanderthal populations, across their entire range from this valley in Syria to the far edge of Europe were themselves gone, their last confirmed populations vanishing from the record by roughly 40s. 1,000 years ago, in most regions, researchers have studied replaced by a species that would go on to write down eventually almost everything else about the deep past, except an explanation for this one abandoned technique. Sourcing material chemistry with this much foresight did not in the end buy the hands that perfected it any more time than the hands that never learned it at all. Whatever else that fact should unsettle in us, it should unsettle the comfortable assumption that being sufficiently advanced is the same thing as being safe. An assumption every species that has ever gone extinct while still improving its own tools has, in its own way, already disproven. Number 1. The Bow of Sabudu Cave and the weapon that decided who you would become. Above the Uthongathi River in KwaZulu-Natal, South Africa, Sabudu Cave has been excavated for more than 2 decades under the direction of archaeologist Marlize Lombard, now of the University of Johannesburg. Among the recovered material was a single bone point found in the ash of an ancient hearth, its body separated from its tip by a fracture old enough to have happened during the object's working life rather than after burial. Publishing with Lynn Phillipson in the journal Antiquity in 2010, Lombard argued that the point, together with a set of small quartz-backed segments blunted along one edge and sharpened along the other, recovered from the same Howisson's port industry layers, constituted the earliest secure evidence anywhere in the world for bow and arrow hunting, approximately 64,000 years old. Those segments are small enough and light enough that researchers had long struggled to explain their purpose using spear or hand-thrown dart mechanics alone, mounted transversely as the leading edge of an arrow cutting rather than piercing on impact. Their dimensions finally made functional sense. Later, high-resolution CT scanning comparing the bone point's internal microcrack structure against points broken deliberately in controlled hunting experiments refined its direct age to 61,700 years. plus or minus 1500, and confirmed damage consistent specifically with high-speed impact rather than heat exposure or accidental breakage. 64,000 years predates the next oldest confirmed bow and arrow evidence outside Africa, the bone points of Fahienlina, described earlier on this list by roughly 16,000 years. It predates any comparable evidence from Ice Age Europe by tens of thousands more, and it represents something categorically different from every other weapon on this countdown, including the spear thrower that opened it. But here's where the difference stops, being a matter of degree, and becomes a matter of kind. A spear thrown or thrust still requires proximity, still ends in a single continuous motion, connecting the hunter's body directly to the target at the moment of the strike. A bow does not. Lombard, working with cognitive archaeologist Miriam Hadel in a joint paper published in the Cambridge Archaeological Journal in 2012, argued that a functioning bow and arrow system demands the coordinated manufacture of 4 or 5 separate components: a stave, a string, a shaft, a stone or bone tip, an adhesive to bind them, each produced independently out of different raw materials requiring different skills, and assembled into a single device that stores energy invisibly in tension and releases it on command at a target. The archer must judge not where it is, but where it will be by the time the arrow arrives. It is planning made physical distance deception and patience, engineered into a single object small enough to carry in one hand. For tens of thousands of years afterward, Homo sapiens shared the African and Eurasian landscape with other hominin populations in the north, with Neanderthals, and more distantly in time and space, with other lineages whose bones and stone tools still turn up in caves. Their own descendants never lived to explain. Every population on that landscape faced the same unforgiving arithmetic of survival: enough food, enough safety, enough successful hunts, generation after generation, with no guarantee that any specific line would make it through to the next one. A weapon that lets a hunter strike accurately from a distance. No animal and no rival expects to be struck from changes that arithmetic in a hunter's favor every single time it works, and it does not have to work by very much sustained over tens of thousands of years to become the difference between a lineage that continues and one that quietly does not. It costs the archer almost nothing to be wrong: a missed shot, a wasted arrow, and it costs the prey or the rival everything the one time it lands. Few technologies in the entire span of human history have shifted that particular cost so far in one direction. Every other weapon on this list — the antler hook, the mammoth ivory boomerang, the heat-treated point, the ivory foreshaft, the cast bronze sword, the poisoned arrow tip, the rainforest arrowhead, the barbed harpoon, the bitumen-fixed spear point — required the hunter to eventually be close to stand within reach of teeth, hooves, horns, or another person's own weapon, and trust their own strength and nerve to carry them through that final dangerous stretch of distance. The bow was the first weapon on Earth built entirely around not having to close that stretch at all. 64,000 years ago, in a cave above a river in South Africa, in a species surrounded on every side by rivals who could match its strength, and in some cases exceed it by a wide margin, someone drew a cord taut between two fixed points and discovered that the balance of survival could be decided at a distance, by people the target never even had the chance to see coming. You exist walking around today with a body built for exactly this kind of patient, distant calculation, because that balance held again and again for 64,000 years in favor of the only line of hunters who happened to be carrying it. Every ancestor between that cave and you had to survive long enough to have children who survived long enough to have children of their own. An unbroken chain stretching back through more generations than any single mind can hold at once, and at more than one point along that chain, the margin between the line that continued and the line that quietly ended somewhere in the dark was not size or speed or raw strength. It was a small, curved piece of wood, a length of cord, and the patience to wait until the distance was exactly right before letting go. If you want to see more videos like this, click the video on screen now and make sure to subscribe.